kinematics, 3E. So you've noticed, or you will notice, you've got two questions there. One question here and one question there. I'm probably just going to go through the first question, and then I'm going to give you an opportunity to have to go on the second question because it's quite similar. I don't want to talk too much. And if you can do that, then it means you can satisfy all the things we need to do with regards to kinematics. So we did do kinematics last year, right at the end of last year, or end of term 3 last year when we were talking about calculus. And we learned kinematics is using functions to describe motion. And so if you've done a bit of physics, this is where an overlap helps a bit. We have S of t is the displacement function. So it's the displacement, that's your position from 0 with regards to time. We have v of t, which is your velocity function. That's how fast you're moving with regards to time. And your acceleration function, which is how fast the velocity is changing. Alright, so they're all related to one another. And so there we've got kinematics is the study of motion of objects. We can use calculus to help us solve it. We've got the displacement, the distance from the point of origin, the rate of change of an object's displacement, and then the rate of change of velocity. And of course that's true. Like if you have y, then dy on dx is the rate of change of y. And so velocity, alright, is going to be the rate of change of displacement, acceleration, the rate of change of velocity. Okay, what else do we get to say there? There's a point about the difference between displacement and distance. Do you need me to explain that? No. There's a point about an object changes direction if its sign changes in its velocity sign diagram. So we'll have an example pop up in a moment. And then we've got what speed is. Speed is just magnitude of velocity. Now you might see that word magnitude pop up a bit. Okay? So velocity is just speed with direction. So you could have a velocity of 15 meters a second. You could have a velocity of minus 10 meters a second. And what the positive indicates is when we're moving to the right, just by convention. Positive velocity means moving right. Negative velocity means moving left. But the magnitude, when we say that word magnitude, it just means how fast. Like remove the positive or negative. What is the size? That's what that word magnitude means. What is the size of the velocity? Well, it's 10 meters a second. That's how fast it's traveling. And then the negative tells you, or the positive tells you which direction. Excellent, let's begin. So we have S of t is this function. This is the position of a particle moving along the x-axis, where t is time in seconds. Draw a sign diagram of the particle's acceleration and velocity functions. So that means we need to find the velocity and acceleration functions. So we'll jump straight into them. That's going to be 3t squared take 18t plus 15. And that'll be 6t take 18. So from here, you can just jump straight on your calculator, sketch both of these functions and draw their respective sign diagram. I'm just going to do it because I can see that's a quadratic. It's going to be quite easy to solve, I think. And we can pull 3 up the front. We'll have t squared take 6t plus 5, which is t take 1 times t and take 5. Alright, so this is for v of t. Alright, so our roots are 1 and 5, and it's a quadratic, it's opening upwards, so plus minus a plus. Okay, one other thing to say is you'll notice the sign diagram stops there, okay? And that's because we only talk about positive values of time. We don't need to consider negative values of time. So this point here is 0, and we're talking about everything past 0. So if you're graphing these functions, all right, only graph them with an x min of 0, and your x max whatever you need it to be. And for a of t, that's going to be the equation of a line that has a root of 3. And that's where it transitions from negative to positive. Okay, you can get all this information from your calculator. I'm doing it because I recognise quadratic opens upwards, line, positive slope, so it'll be positive. I think we've been beating this drum for a while, so if you have any questions about it, please let me know. We'll move on. Okay, so that's done. Find the position and time when it changes direction. Okay, so we are going to refer to our velocity sign diagram here. What it tells us is that for the first second it has positive velocity. That means it's moving to the right. And then between the first and fifth second it's got negative velocity, which means it's moving to the left. And then after the fifth second and on to infinity, it has positive velocity. So if it has positive velocity and then it has negative velocity, it means it's changed direction. It changes direction at these points. So we need to find the position at which they occur. So we've got it changes direction when time is 1 and time is 5. What's its position? That means what's its displacement. So we've got to find, so this is in answer to part B, S of 1 and S of 5. So S of 1 is reasonably easy. I'll take 9 plus 15. So we'll have minus 8 plus 15, positive 7. S of 5, which we might graph it. You can see it's going to be a bit of a nightmare to solve. A piece of chewing gum. It's going to be 5 to the 3, take 18, that's velocity. Yeah, 5 to the 3, take 9 times 5, that's 15 times 5. And so when you're looking at that, you're like, oh, it looks like it's going to take a little bit to put in my calculator. It's worth spending the time graphing the function and then g-solving or using your table function.
Is it 9 times 5 squared or?
Yes, yeah. Thank you, Ben. So, yeah, clear out your graphs. Yeah. Someone's got stuff in them on that. Who's borrowed this one? Alright. X to the 3. Take 9x squared plus 15x. And we're looking for, when x is 5, what is the value of y? Minus 25. Okay, so therefore, let's answer the question. All right, we've got to communicate the maths that we're performing here. Therefore, the particle changes direction when t equals 1 and displacement is 7. Now, sorry, what's our unit for distance here? Yeah, meters. So that's good. Excellent. Okay, when is the particle's speed increasing? Well, let's look at our third dot point in coloured green over there. It says speed of an object is the magnitude of velocity. If v of t and a of t have the same sign, then velocity is increasing. So I might just shove that over a bit. And it's very helpful when you're doing these problems to draw these sign diagrams right underneath one another. Okay? Because then you can see, they have a different sign over this region. Over the first second, velocity is positive, acceleration is negative. Alright? But then between 1 second and 3 seconds, they're both negative. Okay, so what that means is it's got negative velocity and it's accelerating in a negative direction. So its speed is increasing. The magnitude of its speed is increasing. The magnitude of velocity is increasing. So we can see that they're both negative there. Alright, so that's going to be our first answer. Is that from the sign diagrams? Okay, that speed is increasing over this interval. And then, after 5 seconds, both velocity and acceleration are positive. Okay, so it means it's moving in the positive direction and accelerating in the positive direction, and so speed is increasing. Okay, part C, part 2. When is velocity increasing? Okay, so let's make a connection here. The simple answer is velocity is increasing when acceleration is positive. Alright? Now let's try and make a connection as to y. Remember, if we have the function y, okay, dy on dx is going to tell us about the slope of y. And so if dy on dx is positive, right, let's say this is just the sine diagram of dy on dx. If dy on dx is positive, it means y is increasing. If dy on dx is negative, it means the function y is decreasing. So, remember, acceleration is the rate of change of velocity. So velocity is going to be increasing when acceleration is positive. So that's part I, this part I. Velocity increasing when t is greater than 3. That's when our acceleration is positive. Okay, find S of 6 and draw a motion diagram. Find S of 6 up here, A, B, C, D. Okay, and this is where it's helpful to have the graph. We've got the graph already, so we don't need to waste time typing all that in again. And x is 6, y is minus 18. Okay, we're ready to draw the motion diagram. So a motion diagram then is a axis, it's a horizontal axis, and it's just a demonstration of where the particle begins, where it moves, and where it ends. So we'll just draw an axis along here, and we just put those minimum and maximum points at the far ends. So the furthest to the left that it is minus 25. Let's say that there, minus 25. And the furthest to the right it is positive 7. And so 0 is going to be about there. And the other point of interest is minus 18, which is about there. Alright, so let's plot all that information on there. It wants us to find S of 6 and draw the motion over the first 6 seconds. Okay, that's okay, except we haven't found S of 1 either, S of 0. Alright, so that's going to be initially where it begins. When time is 0, what is the position? Well, that's an easy one. 0, you plug 0 into this equation, you're going to get 0. So this is where it starts. So we can put on there t is 0. When t is 0, on this axis here, this is the displacement position. So that's where it starts, and initially we're going to make lots of connections here. It's moving to the right, and after 1 second, S of 1 is 7 meters right. So this is going to be, that's where it gets to. That's when t is 1. It's at 7 meters. At that point, okay, from our velocity diagram, it changes direction, which means it's no longer moving to the right, it starts moving back to the left. And in fact, it does so until it gets to minus 25 meters after 5 seconds. And then it changes direction again and finishes here when t is 6. I'm going to draw an arrow so it's going to go that way forever. Okay, now let's make sure we read things carefully because it says, hence find the total distance travelled in the first 6 seconds. Alright, so here we've got this is its final displacement. That's how far it is from the point of origin at the end of 6 seconds. But we know how far has it moved in total in 6 seconds. Well, from here to here was 7 meters. Okay, from here to here is 7 meters. So we're already at 14 meters. And then the question is, what is the distance between these 2 points? And that's going to be, well, from there to there is 25 meters. And from there to there's again 7 metres. So that whole distance is 32. And so total distance, let's make a moment, 7 plus 32 is 7. 1446 metres. Excellent. So I'd love you guys to have a go at the question open page. Okay, use your calculator to support you, and then we can move on to exercise 3E.